So this is a video lesson on section 9.3, which is special cases in multiplication of polynomials. So in 9.2 we talked about multiplying polynomials. If you remember, we did binomials times binomials, binomials times trinomials, and we used various methods like the FOIL method, first, outer, inner, last. We used the table method for both binomial, binomial, and binomial and trinomial multiplications. We used the clamshell method, also the vertical and the horizontal method as it's called. So there are multiple ways of multiplying out a pair of polynomials. So today I'm going to show you a shortcut method that works with certain exceptions or certain special cases of these multiplications of polynomials. It doesn't work in every case, but when it does work, it's much quicker, much simpler, and much safer to do. You don't have to use it. It's an optional shortcut, but it does make your life a little bit easier if you do decide to use it. So for example, if I gave you a problem like this one, x plus 8 taken to the second power, if I didn't give you the shortcut method, this is probably how you would solve the problem out. You would write down x plus 8 times x plus 8 because it's x plus 8 taken to the second power, so it's being multiplied by itself. And then you would probably FOIL it out or table it out if you so like to choose that particular method, but I FOILed here. So I did my first, then I did my outers, then I did my inners, and then I did my lasts. So here is the end product of the FOIL, and then here's the answer that has been simplified. So, and you can always use the FOIL or the table method to solve this particular problem, but there's a shortcut method of dealing with this special case. And the special case here is a binomial that's taken to the second power. So any binomial that's taken to the second power, you can either do it the old way, which is just laid out next to each other, the two identical binomials and multiplied, or you can use a shortcut method. The shortcut method has 3 steps. This is the first step. Square the first term. My first term is an x. So I'm told to square the first term. So the x is going to go and turn into an x squared because I'm squaring the first term. Second step is square the second term. Alright, my second term is an 8. I'm going to square it, and 8 to the second power, 8 times 8 is 64. Third step, this is the slightly more difficult step of the 3 here, is multiply the two terms and double them. So what does that mean? Alright, so my two terms are x and 8, so I just told you multiply them. So multiply x and 8 and then double it, which means multiply everything by a 2, which gives you 16x. And then put the 3 resulting terms in standard form, which means highest degree monomial goes first, lowest degree goes last. So x squared plus 16x plus 64, and that's the answer. Same as the method before, but once you get used to the shortcut, you don't have to FOIL it or use a table method. You skip this whole step where you combine your like terms. It's safer because, again, you skip a step, and whenever you can skip a step in math, it's great because it's one less step that you can make a mistake on. So let's do another example of this particular method. So let's say I gave you a problem like this one. So here's about as difficult of a problem as you're going to encounter for this special case. So again, the special case works here because it's a binomial that's taken to the second power. It's the same binomial being multiplied against itself. And you can always use the FOIL method. You know, if you really, really wanted to, you could write it out like this and just FOIL it out. And it would work, but it would be a bit messy and it would take you longer. Let's say you didn't do that. Let's say that you decided to use the shortcut method. So forget that that's there. And let's take a look at the original problem. So we're pretending that we're not doing the FOIL method. So the first step tells us to square the first term. So if you recall the steps before, the first term says square the first term, where the first term is 10k squared, and if I square it, I get this. So the entire term squared, which then, if you remember of power to the power problems where you can distribute the external exponent to the internal exponent, it's 100k to the fourth power. Okay, first step done. Second step, square the second term. Well, the second term is a -3, and it's a -3, not just a 3, and I'm being told to square it. Sure, that's nice and easy. -3 times -3, well, that's a +9. And then I'm told to, for the third step, multiply out my two terms. So I'm going to multiply 10k squared and the -3, and then I'm going to double everything. So, and then just double it. So multiplied by 2, in other words. So that gives me -3 times 10k squared. That's a -30k squared. And if I double that, I get -60k squared. And that's it, I'm done. And this, again, this is a more difficult problem if you were to FOIL it out. So it looks like it's complex here. If you were to FOIL this out, this would be complex with the foiling process as well, more so. So if you put this answer in standard form, this goes first. The fourth degree 100k to the fourth power goes first, and minus this and plus our 9. So that would be the answer. I didn't do any foiling or any table methods. I skipped the step where I had to combine my like terms. All there. That's the answer. So you can use the shortcut method. You don't have to use the shortcut method. I think it's great. I think it's easy and it's safe, but that's going to be up to you. So this was the first exception. I'm going to show you now the second exception. The second exception, or the special case, has its own shortcut, and I'll show you that as well. Okay, so now we're going to talk about the second special case, or the second exception. Here we have x minus 1 being multiplied by x plus 1. Very similar binomials. They're almost identical, but they're not identical because one has a subtraction going on, the other one has an addition going on. So they're very, very similar, yet a little bit different. So you can't use the previous shortcut because they're not an identical binomial being multiplied by itself, but it's pretty close, and this particular special case has its own shortcut. And the shortcut here is even simpler. So it goes like this. Square the first term. So the first step is square the first term. The second step, subtract the square of the second term. That's it. 2 steps, and you're done. Now, just like before, you can FOIL this or use a table method to multiply those binomials, but this is so much simpler. For example, the first step says square the first term. Which term to use doesn't really matter. You can use the x here or the x here. They're both first terms. Which one you use doesn't really matter. So I'm going to square it. And x to the second power is just x squared. Done. Then I'm told to subtract. So it's going to be a minus the square of the second term. Well, I have actually 2 different second terms. I have a 1 and a -1. Which one do I choose? It doesn't matter, because squaring a 1 is a 1. Squaring a -1 is still a 1, because if you take a negative number and square it, you get the same number. So minus 1 squared, which is just 1 itself. So the answer, x squared minus 1. As simple as that. No need to FOIL anything, just all ready to go for you. Let's do another example here. I have this particular problem. Alright, for this problem, again we're going to use that second shortcut method because this is the second special case where you have pretty much an identical binomial except one has an addition in there and the other one has a subtraction. So the shortcut says, well, first take the square of the first term, no problem, I can do that. The square of the first term is 3s taken to the second power. Then subtract, so minus, and it's always a minus. With a special exception, it's always a minus. The square of the second term, doesn't matter which one I choose, let's say I choose this one, negative 8 square. So square the first term, subtract the square of the second term. And I could have used a positive 8 or a negative 8, it doesn't really make a difference. So that gives me 9s squared minus negative 8 times negative 8 is a positive 64. That's it. That's the answer. As simple as that. Let's do one more quick example. So again, second special case or second exception, use the second shortcut method, which is square the first term. We're going to square the first term, doesn't really matter which one you choose. Subtract, so always a minus, the square of the second term, doesn't matter which one you use. You can use this one, you can use this one. Let's say I use this one here. So square the first term, subtract the square of the second term, which is 4x squared minus 3 squared, which is 9. Done. No foiling, no table method, super simple. So you don't have to use the shortcuts. I encourage that you do. They make your life a little bit simpler, and if you can make your life simpler, why not do it? So thank you very much.